All right, hello everybody, and welcome back to VSAT. Today we're going to be discussing managed allowable depletion as well as soil moisture depletion, and we're going to introduce a few new calculations for you guys to help with the agriculture irrigation specialist course. So moving forward, a new term that we're going to introduce to you today is plant available water. All right, now plant available water is similar to available water, but the biggest difference is in available water, when we discuss available water, we're looking at 1 foot of soil and how much water is available in that foot of soil. But what happens if your root zone, here's my crop, and we're growing something like tomatoes or whatever that has a root zone that's deeper than the 1 foot of soil. So we're addressing a root zone with multiple feet of soil. Available water only takes into account how much water is in each foot, where plant available water calculates how much water is total amongst all the feet that the root zone comes in contact with, because the root zone can draw water from every single foot that it comes into contact of soil, the soil that it comes in contact with. It's not limited to just 1 foot of soil. But we need to know how deep our root zone is, and we need to know the available water for each foot of soil. And if we know those two things, we can then calculate how much water is available total for the plant. And then if we know how much water is available total for the plant, we can then track how much moisture we deplete in between irrigation cycles. And if we could track how much water has been depleted between irrigation cycles, we then know how much water we need to put back into our soils during the irrigation period. So that's what we're going to discuss today. So the first calculation we're going to look at is available water. Again, that comes in inches per foot or a percentage. And I always like in this equation to convert my available water into inches per foot, because I think it's much easier to understand. We multiply that by our root zone depth, and our root zone depth we want to find in feet. So we may know how deep our root zone is in inches, and if we divide that by 12, that'll convert the inches to feet. And if we multiply the available water in inches per foot times the depth of the root zone in feet, we can calculate our total plant available water for the entire plant in its root zone, and calculate how much water is available beyond just that first foot of soil that the available water takes into account. So here's a description of a question that you might see when we get to the quizzing period, and here's how we utilize this equation. Tomatoes with a 4 foot root zone are grown on sandy loam soil. If the available water is 1.25 inches per foot, what is the plant available water? So in this case, we know what our RZ is, right? The root zone, or RZ as we refer to it, is 4 feet, and our available water is equal to 1.25 inches per foot. Now again, I always like to write my equations out, and what I would suggest to you is last week we covered field capacity minus the permanent wilting point equals the available water. Now we got a new equation. Available water times the root zone equals plant available water. And what I would suggest doing, because we're going to throw 2 new equations at you today, another equation at you at the end of the week, and a few more equations by the time this course is done, is just take a piece of paper and leave it blank except for the equations that we're throwing at you. That way, when we give you guys questions, and we want you to solve for certain information, you can look at the information that we provide you and compare it to that sheet of equations, and the equation that fits the information that we give you the best is the equation you want to use to solve for whatever we're asking you to solve for. So going back to available water times root zone equals Paul, all I have to do in this scenario is plug in my available water, which is 1.25 inches per foot, times it by my depth of my root zone, which equals 4 feet, and that comes out to a total Paul of 5 inches. All right. What happens in the multiplication process is the feet cancel each other out, and we're left with this inches here. So Paul is always in inches. Now, what happens if you know that the root zone is 48 inches. In this case, you want to convert it to feet. So we divide by 12, and that comes out to 4 feet. And if we have our available water in a percentage, we want to convert that to inches per foot, and then we can just plug those numbers in and solve for PAW. So again, the biggest difference between PAW and available water is PAW accounts for a root zone that is deeper than a single foot of soil. And available water looks at each foot of soil and determines how much water is available within each foot. All right. Now we're going to jump into managed allowable depletion. All right. The term management allowable depletion, management refers to a decision made by the farmer or the irrigator. All right. He's managing this decision process. All right. And what the managed allowable depletion is, or MAD, is when we know what our available water is. And keep in mind, our available water is that space between field capacity and the permanent wilting point. So that's the amount of water that's available for the plant to use before it hits to a point, that permanent wilting point, where it begins to die. All right. So what we do with our managed allowable depletion is we set a trigger line that says when my depletion of moisture in my soils hit a certain point, I'm going to irrigate. All right. And there's many factors that can contribute to this decision. One is access to water. All right. Now, you may be limited to access to water, and sometimes where you're farming, and depending on the infrastructure, that may be the case. Maybe you can only farm at night. Maybe you can only farm certain days of the week. Maybe you get a pump rate because the pump size is only a certain amount of gallons per minute, and that may make you want to be more proactive and irrigate more often than not. The biggest use of managed allowed depletion is we never want to hit the permanent wilting point, right? If we hit the permanent wilting point, the plant begins to wilt and die. So we always want to irrigate before we get to that point, and we want to fill that soil reservoir up. But we never want it to hit that permanent wilting point. So one of the uses of managed allowable depletion is to ensure that we're never going to hit that permanent wilting point and see reverse effects on our crop. So the unique thing about managed allowable depletion, it's always used in a percentage. All right. Now, field capacity, permanent wilting point, available water, we always use that in either inches per foot or a percentage. Management allowable depletion, or MAD, is just a percentage. All right. So when we use it in equation, if we know the MAD is 60%, when we use it in the equation, we express it as 0.60. But there's no converting it to inches per foot or anything like that. It's always used as a percentage. When we plug it in an equation, we should convert it to a decimal. Again, 60% should be 0.60 if that's the managed allowable depletion. The larger the management allowable depletion, okay, the larger the MAD, the more water you're allowing to deplete before you irrigate again. Smaller the management allowable depletion means you're going to be irrigating more frequently and allowing less water to deplete before you decide to irrigate again. And again, there's many factors about why you would do this. Guys who are doing flood irrigation, for instance, because they use so much water when they irrigate, and because that water is makes the soil extremely wet, they tend to use a MAD that's much greater because they want to deplete as much of that moisture as possible to ensure, again, fresh oxygen in the root zone, and because the cost of water sometimes can be tricky. Guys using drip and micro irrigation tend to have a MAD that's much smaller, meaning they're going to irrigate more frequently because it's difficult to put large amounts of water in the soil using drip irrigation. And like we do on hydroponics, we don't want our root zones stretching out so it can have access to more nutrients. We want to limit the size of our root zones to an extent. That way we can focus that energy on producing foliage and fruit. So we want the plant to have access to water, fresh water and nutrients at all times, so we tend to use a smaller MAD. Now, how do we derive a management allowed depletion? First, we have to know what our available water is. How do we know what our available water is? Typically, we start with that equation we learned last week about field capacity minus the permanent wilting point. If we know those two those two variables and we can solve for available water. Then when we solve for available water, what we do when we determine what our management allowable depletion is, we take a percentage of that available water, and that helps us determine what the depletion rate will be when we irrigate. All right, so let me walk you through this. The new equation we're going to learn now is available water times MAD equals soil moisture depletion. All right, so let's walk through one of these together. If management allowable depletion, MAD, is equal to 28%, and the available water is 2.2 inches per foot, SMD, and this is a new one for you, SMD stands for soil moisture depletion. If we know available water and we know it, we establish our MAD, then that's going to tell us how much water is depleted in between irrigation cycles. Now, why is that important to know? If I know how much water has been depleted between the last time I irrigated, now I know how much water I need to put back in the soils to maintain that distance between permanent wilting point and field capacity. See, most farmers, they want to fill their soil reservoirs up to field capacity. If you start getting down below field capacity, you're not irrigating all the way up, at some point you might find deficiencies in access to water and so forth. Most farmers also don't want to ever pass field capacity and hit saturation, because a lot of times that's just wasted water. Sometimes we need to, and in the sense of avocados are very salt intolerant, and we tend to use the saltier water from the Colorado River. And as we apply this water, that salt content builds up in the upper inches of the soil. And so we typically apply more water to hit saturation. That saturation leaches that salt layer below the root zone, so it doesn't cause stress on the crops. But the vast majority of the time, we just want to fill up that soil reservoir to field capacity. And if we know how much moisture has been depleted, soil moisture depletion, in between that last irrigation cycle, we can put back exactly how much water has been depleted, reach field capacity, and not be wasteful with our water. So again, we need to know our available water, and we can determine what our available water is if we know what the field capacity and the permanent wilting point is. We establish the management allowable depletion. This isn't something that you can go out and find. This is something you, as a farmer or irrigator, establish. And then when we know these two things, we can determine how much moisture has been depleted since we last irrigated. All right, so if we plug these numbers in, available water is 2.2 inches per foot. Again, management allowable depletion is always a percentage. So 2.2, if MAD is 28%, I express it as 0.28. And that gives me a soil moisture depletion. In fact, I'll need to break out a calculator because I can't do that in my head. That gives us soil moisture depletion of 0.62, in this case, inches per foot. So now I know that if my root zone is only a foot deep, then that means I need to put back into the soil 0.62 inches of water. If my root zone accounts for several feet deep, then I need to reevaluate, because I'm at 2.2 inches per foot, right? So if I have a root zone that's multiple feet deep, I'll need to times this number by how many feet our root zone is going down to determine how much water has been depleted through the entire root zone. All right, but again, MAD, key thing here, MAD is always expressed as a percentage. If we know available water, we know MAD, we can determine how much moisture has been depleted in irrigation cycles, and then we know how much water we need to put back into the soils when we irrigate, so we're not being wasteful when using water as efficiently as possible. That concludes it for early this week's math, and we'll come back later this week and discuss a new equation later on. See you next time.